All right, welcome. My name is Rick Marshall. I'm the Director of Safety for the IFCEE. This is a multiple faceted demonstration here today. Your focus is on the rebar cages that you see behind us, but we also want to talk about a couple of safety issues. The ground you're standing on right now, what would you call that? I'm calling it a working platform. We got all kinds of equipment out here. Visually, it looks great, terrible, unsavory. What do you think? This is where you guys participate. It's not just us talking here. Looks great because it's asphalt. It's a beautiful parking lot. But if you looked around, you see we've already patched I don't know how many holes because we've already punched through on a nice hot summer day. So standing behind me on the working platform that we created is a machine that costs somewhere, I'm guessing, maybe I'm wrong, in the $1 million plus range. How many wants to donate their crane as it turns over working on garbage? I see no hands. So for you guys that work in the field and you're actually willing to risk having a piece of equipment like this behind me, walk, tram, lift, swing, do all the stuff that a mobile crane can do, a foundation drill rig can do, a dedicated pile driver can do, on a platform that visually looks good but has the capacity of sinking at the moment's notice, you might be spending an awful lot of money with your insurance carrier, your client, your logo is plastered all over your piece of equipment. So one of the things we try to demonstrate is the difference between what looks good and what's actually good. Some of you people have already noticed that the whole parking lot is on its slants, unfortunately. So when this mat was constructed, it followed the pavement. So yes, indeed, the crane is out of level. We've compensated for it. We understand that. Our operator is an expert at doing what he does. He understands that. We are not going to lift the cages 50 feet in the air. We're just going to demonstrate them distorting. So my lead-in was about the safe working platform. I'm going to turn the microphone over to the Tensar people, the fabric people here, to have them explain to you how this platform was created.
All right, everyone. My name is Ethan Johns. I'm the field engineer for Texas. I work for Tensar. Tensar is the manufacturer for GeoGrid. So that's a geosynthetic. It's a little different from like a fabric that you would use in the fact that it uses aggregate confinement and bearing capacity, improved bearing capacity to help improve with loading. So what it is, it's a polypropylene material. It's punched and drawn. And this roll behind me is what it comes out and looks like. Basically, all you have to do is, with just a couple people, just take it, cut it, roll it out on top of your subgrade, and then you can build your platform on top of that. So it's a very simple process. You don't need heavy machinery to move it around. Me and my coworker Trevor LeBou out there, he is the regional manager. We were able to install it in just like 20 minutes. Really easy, just kick it out and roll it. So basically what it does is that you're able to use the aggregate on top to confine the material to strengthen the platform and give you a good working platform to work on. So we do a lot of different types of designs. So obviously we have our working platform. We can do access roads, heavy haul roads, even under pavement. So some typical solutions that you might see out in the field is chemical stabilization. That's normally a pretty big one. You can use wooden mats, and then you can just put a whole bunch of aggregate base on there to build up your material to get a strong pad. But with our method, we use our GeoGrid, and you can cut down on how much aggregate material that you actually need. So for a section like this, we have 6 inches of aggregate base, our GeoGrid, and then 6 more inches of aggregate base. And we call that mechanical stabilization. So if you're going to be doing your designs for your platform, if you don't get a GeoGrid solution, we ask that you please just ask for that from your geotech or whoever's doing your design, because it can save a lot of money. and it can provide better support. Let's see, what else do we have here? So basically, if you don't want to send it to your geotech, you can always send it to us. We're more than happy to help. The only thing we ask is that you give us the required bearing capacity for your equipment, or the critical lift, and then your strength parameter for the subgrade. And then what we deliver is your allowable bearing capacity with your factor of safety. So we can do that in shop. We have a bunch of engineers dedicated to doing working platforms. Besides how young I look, I know I have a baby face, but I am a professional engineer. And then so our development and specifications. So we don't just throw it out there and say, oh yeah, like it'll work. Basically, we have done a lot of in-ground testing. We have proven results. We have third-party testing as well. So we're not just throwing it out there and be like, hey, we're good, we're supported. And lastly, a lot of people ask if you can drive piles or drill through the geogrid, and if it's gonna mess it up, tear it up. It will puncture right through, and we will have no issues, and people do it routinely all the time. So there's no issues with that. And if anyone has any questions, you can come talk to me and Trevor. We'll be right here at that table. And without further ado, here's Eric.
Hey, thanks for coming out. My name is Eric Austell with Foundation Technologies. We're based out of Lawrenceville, Georgia. We sell rebar accessories, cage centralizers. You see the CSL tubes that are tied to the cage today. It's called Sonatech. Also helical piles in the southeast and the west coast. So what we have today, one of the, I guess, sticking points or objections that we get from contractors and wanting to use Sonatech is its durability. It's a thinner walled pipe. It features a push fit connection rather than it being threaded and coupled like the Schedule 40 pipe. The advantage to that is it's much lighter and easier to use. So myself and a couple of my coworkers, we got that cage tied up in about 20 minutes. Didn't take very long at all. Very easy to handle. Like I said, lightweight. It's secured at the joint between tie wire and adhesive. So we use a 3M number 90, like a green can adhesive. There's also a watertight seal on the inside. Another one of the main benefits is its flexibility. So it's a thinner wall. It's not as rigid as the Schedule 40 pipe. So some people, they come back and say, oh, it's not as durable, or it's not going to work as well, whatever the complaint is. We've been on several jobs where the cage has deflected a lot, much more than, what you want to, almost to an unsafe matter. But like an S in the sky, it's a 140-foot cage. But the tubes held up just fine and did exactly what they were supposed to do: hold water in and keep concrete out. So, whenever they pick it, you'll be able to see the flexibility of the tubes and its durability. So, if you want any more information, we're at booth 305 inside in the AC.
All right, good afternoon. I'm Ray Fassett. I am the chairman of the ADSC Drill Shaft Committee. 2020, I think we brought this research project from Charles Pankow, UNR, IFCEE, to look at a mechanical connection for rebar cages to kind of help in the stability when picking cages. Obviously, those of you that do it know that you're relying on a piece of wire basically to hold the rebar cage together, right? So the idea was to come up with a U-bolt clip style that was easy to put on and easy to use. UNR did a series of tests on this. So they tested a wire tie. And I would say that from the standpoint of a vertical capacity, you could probably get about 1,000-pound capacity out of that tie. Typically a double wire 15 gauge wire tie. But in the normal position, in other words, as we pick it from horizontal to vertical, it's only good for about 250 pounds. So now you're having to downgrade that tie, right, to be able to understand what you need for the capacity in order to make that cage stay together. In this particular case, in the vertical position, these U-bolts will do about 10,000 pounds. So that's maximum ultimate, if you will. So, we're talking at least 5 times the capacity in what a regular tie wire gives you. The idea is that it gives you some stability. There's a series of there's a guideline that they put together, and there's 2 documents actually that UNR produced that's available. IFCEE has it on their website. Now that we've portrayed it here, we'll make sure it gets on the ADSC website. And it basically walks you through all the different things that they did, the number of clips they needed, etc. I will tell you that the cage we're going to pick with the clips on it today has way more clips than you would ever need on it. But the intention is to show you what it looks like with that many. And then over the course of the week, we hope you guys will come back and we'll do this again and again. With less and less clips and get it down to the final configuration. So there is a table in the document that gives recommendations on how many clips you would need. And for this particular cage at that diameter, you really only need 4 at each hoop, and you really only need it on 8-foot centers. And we're double that right now. So we'll take a look and see what it is. So the intent right now is we will pick this cage that is just your standard tie. Kind of show you what the deflections look like and things like that, and then we'll re-rig and we'll pick the second one. So whenever you guys are ready. So you can see here the deflection in the cage. Maybe it's okay, maybe it isn't. Maybe you're gonna bend the CSL tubes, maybe not. Maybe you'll start popping some tie wire, maybe not, but not ideal. We'd like to see this pick relatively flat. So while they do the swap over the rigging, the first thing I'd like to say is thank you to PJs. They tied these cages, brought them all the way from California for us. I'd also like to thank LeBear for the donation of the crane. Couldn't do it without any of them. So hopefully you guys are getting some benefit out of seeing this in real life. For those who don't know or haven't seen it up close yet, so this is what we're talking about. It's a double U-bolt system, basically. So 2 run-of-the-mill U-bolts, if you will, and 2 plates. The whole intention of this is you put this on the cage and you tighten the bolts until the plates deflect 5 degrees. There is a foot-pound component if you'd like. It's 75 foot-pounds, but really that deflection is all we're looking for. And then the clips are good to go, and you get that capacity that we talked about. I will say that all of the testing was performed in a single bar situation. We haven't looked at bundles of 2 or even bundles of 3. And that may require looking at maybe the shape of the U-bolt itself to try and get square corners to pick a double bar, and then a very large U-bolt to pick a triple bar if that was something you did. In conversation with Vincent Seifert, he was representing IFCEE for this research. He had a good point in saying we leave the Z braces in and we look at just putting the clips at the Z braces, because that's really what we depend on, right? When we pick cages, we're looking for braces. We try to rig it in the points of where the braces are, and maybe that's all that's necessary. But we didn't test that. UNR didn't. There is a secondary testing coming up that maybe that can be looked at as well. I can tell you they did this in their lab where they actually took out all the cross bracing, and they were able to get better or less deflection than we would with any kind of Z bracing we've ever put in it. So the clips work. It's just trying to get it down to an economy of how many clips do you need. Oh, and I should say that the clips were produced by Williams Form Engineering, and they donated the ones for the actual research as well. So it's key to note we picked the first cage, basically 4 feet down from each end to show the deflection in the cage. When UNR did their research, they looked at it either from the end and then they moved the rigging points in. They looked at how much of a cantilever can you have on either end before it affects the deflection, etc. So we're going to pick these off of at 4 feet in as well and see if we see any difference between the two different cages. And then when this is all said and done and we lock off the crane and stuff, you're welcome to walk up to the cage and take a look at it. There's also some HRC connectors on the end of the cage that you can look at. And if you want to see these up front, you can come grab it from Vince.
They can see how easy they are to put on.
Yeah, yeah. So you can come up and look at and see how easy it's going to be to put it on a cage. And like I said, we have twice as many on here than we needed. Do you see a notable difference? And see how this is helping with the stability of the cage itself? That's good. That's enough. Yeah. So big difference between it. Hopefully you guys will come back later in the week, tomorrow. By Friday, we're going to have this stripped down to hopefully 4 clips per location at 8-foot centers, and we'll see the difference between it all. Tomorrow, we're going to take off every other set, so it'll be 8 at each hoop, but it'll be on 8-foot centers. So hopefully you guys like what you saw. If you have any questions, please feel free to come up and ask. Also, in addition to PJ's, Nucor provided the reinforcing for the test program itself, right? So, any questions, let me know, please. Thank you.